Hello everyone. So welcome to the week 10th of this tutorial session on principles of signals and system. So today we are basically going to discuss about the questions based on discrete time signals, DTFT, DTFS, and we will see about those signals. We have already solved lots of questions based on the continuous time. So if students who are not watching this lecture can watch in the YouTube, and if they have any doubt, then they can ask in the comment box. I will reply there. So, first of all, uh, I will give some of the basics formula, like the representation of discrete time Fourier series. So, discrete time Fourier series representation is given as x of n can be represented as summation of ck e to the power of j 2 pi by n a small k into a small n. Here n is equal to 0 to n minus 1. So period of this signal is n. Okay. And ck is the, I'm sorry for the disturbance. Ck is the Fourier series coefficient, and given as ck is equal to 1 by capital N summation of k is equal to 0 to n minus 1 xn into e to the power of minus j 2 pi by capital N into kn. Thus, Ck and Xn makes discrete time Fourier series coefficient pair. Okay, so this can be represented at this. So we have already studied like Ck is periodic with n, and Ck repeats after every 2 pi interval at the omega axis. Now we will see some of the questions like find the DTFS coefficient of signal xn is equal to sine of 2 pi by capital N into N. So here xn that is equal to sine of 2 pi by N into N. So this can be written as e to the power of j 2 pi by capital N minus e to the power of minus j 2 pi by N into small divided by 2j. So in this way we can write sine 2 pi N into N. So now our xn that is equal to 1 by 2j e to the power of j 2 pi by n into n minus 1 by 2j e to the power of minus j minus 1 2 pi by n into n. So here C1, that is the Fourier series coefficient, that is equal to 1 by 2j, and C of minus 1, that is equal to minus 1 by 2j. Okay, here k is like k into n, so here k is our minus 1. Okay, here k is plus 1. So this is very simple question. If you have any doubt, then you can write in the comment box. So before moving into the DTFT part, we will see some of the properties of DTFS. Okay, I will check whether this video is recording or not. Yeah, it's getting recorded. So in this properties of DTFS, the first property is linearity. So linearity is given as alpha into x1n plus beta into x2n have the DTFS as alpha ck plus beta d. Okay. The second one is time shifting. In this, x of n minus n naught will have e of minus j 2 pi by n k n naught into ck. Okay. The third one is frequency shifting. This time x of n into e to the power of j 2 pi by n into capital of mn. This will have DTFS as c of k minus n. Now the next is time reversal. So x of minus of n, this have DTFS as c of minus of k. After that it is time scaling. In this x of n by n, the DTFS of this will be 1 by m into c of k. If n is multiple of n. Sixth one is periodic convolution. So x1n when convolved with x2n, the DTFS of this will be n dot ck dot dk. Okay, ck and dk are the coefficient of x1n and x2n. So these are the main one. Next one we'll see conjugation and Parseval's relation. So conjugation is given as x conjugate of n will have DTFS as c conjugate of minus k. Eighth one is Parseval's relation. So Parseval relation is given as 1 by n of summation of xn squared This is equal to summation of mod of ck square. Okay. So after this discrete time Fourier series, we will study about discrete time Fourier transform. So first we will see the definition of discrete time Fourier transform. So dtft of xn is equal to x of omega. That is given as summation of xn into e to the power of minus j omega n is equal to minus infinite to plus infinite. Okay. So now if you do the inverse discrete time Fourier transform of x omega, then we will get x of n. So this is equal to x of n. That can be written as 1 by 2 pi integration of 2 pi x of omega e to the power of j omega n d omega. Okay. So in this way, we can find the discrete time Fourier transform and the inverse discrete time Fourier transform. X omega function of omega is periodic of 2 pi. So x omega of plus 2 pi, that is equal to x of omega. So we have proof for this also. That is x of omega plus 2 pi, that is given as summation of x of n e to the power of minus j omega plus 2 pi into n. Okay. So this will become summation of n is equal to minus infinite to infinite x of n e to the power of minus j omega n into e to the power minus j 2 pi n. So existence of DTFT is said to be exist if xn is absolutely summable. Okay. So the DTFT x of omega is said to be exists if xn is absolutely summable. So x of omega, that is equal to summation of xn into e to the power of minus j omega n. Here n is equal to our minus infinite to infinite. We all know that magnitude of minus e to the power of j omega n, that is equal to 1. So if x of n is some finite value that is less than infinite, like summation of x of n, then this is sufficient condition for the existence of DTFT. Okay. So now we will take some of the examples and we will solve the uh, question for that. Find DTFT of xn is equal to a to the power of n un. Okay. Mod of a is less than 1. So here x of omega, that is equal to summation of xn dot e to the power of minus j omega n is equal to minus infinite to infinite. So this can be given as n is equal to minus infinite to infinite. Here xn is a to the power of n u n. Okay. So x omega is equal to summation of n is equal to 0 to infinite, because for negative value of n, un is equal to 0. So it will become an e to the power of minus j omega n. So this will become a e to the power of minus j omega into n. Okay. So our x omega, that is equal to 1 by 1 minus a e to the power of minus j omega. Okay. So the dtft of an un will be 1 by 1 minus a to the power of e of minus j omega. So now let's take an example so that un have Fourier transform of pi of del omega plus 1 by 1 minus e to the power of minus j omega. Here omega is less than equal to pi. We know that, let's suppose un have Fourier transform that is given as x of omega. Then del L is equal to u of n minus u of n minus 1. Now take Fourier transform on both the sides. So we have 1 is equal to 1 minus e to the power of minus j omega x of omega. Okay. So here 1 minus e to the power minus j omega is equal to 0 for omega is equal to 0. So x omega must be of the form as x omega is equal to a of del omega plus 1 by 1 minus e to the power of minus j omega. Okay, where a is a constant. To determine a, we proceed as follows. The even component of un is given as half plus half of del n. and the odd component of un is given as u of n minus u of even of n. So this is equal to u of n minus half of del of n. So Fourier transform of u of n is equal to a of del omega plus 1 by 1 minus e to the power minus j omega minus pi of del omega minus half. Okay. So the Fourier transform of all real sequence must be purely imaginary. Thus we must have a is equal to pi. So an odd real sequence must be purely imaginary. Thus we must have a is equal to pi. Therefore, u of n have Fourier transform as pi of del omega plus 1 by 1 minus e of minus j omega, and mod of omega is less than equal to pi. So this DTFT also follows the properties of linearity, time shifting, frequency shifting, and all other properties. Okay. So let's suppose x1n have DTFT of x1 of omega and x2 of n have DTFT of x2 of omega. So alpha of x1n plus beta of x2n have DTFT as alpha x1 omega plus beta x2 omega. Okay. Now the second one is time shifting. So x1 have DTFT of x of omega, x of n minus n naught have DTFT as x e to the power of minus j omega n naught x of omega. So we can prove this also. So dtft of x of n minus n naught is given as summation of n is equal to minus infinite to infinite x of n minus n naught e to the power of minus j omega n. So now substitute n minus n naught is equal to m. So it will become x of m, summation of x of m e to the power of minus j omega and naught plus m. So this will become e to the power minus j omega and naught summation of x of m e to the power minus j omega m. Here m is equal to minus infinite to infinite. So this will become e to the power of minus j omega and naught x omega. Okay. So now let's suppose take an example. If the Fourier transform of x of n is x omega, then the Fourier transform of minus 1 to the power of n x n is. So the dtft of xn is given as, let's suppose, of x omega, then minus 1 to the power of n xn is equal to, it is written as e to the power of j pi into n into x of n. So now we have to find the dtft of e to the power of j pi n into xn. So this have dtft of x of omega minus pi. So by using this property, e to the power of j omega naught n xn will have dtft as x of omega minus omega naught. Okay. So now we will solve another question. The discrete time Fourier transform dtft of xn is equal to 2 to the power 2 into 3 to the power of n u of minus n is equal to, so we have to find this. So solution will be a to the power of n un has dtft of 1 by 1 minus a e to the power minus j omega, and now a to the power minus n un u of minus n will have dtft as 1 by 1 minus a to the power of e of j omega. So let's suppose here xn is equal to 2 into 3 to the power of n u of minus n. So this can be written as 2 into 1 by 3 to the power of minus n u to the power minus n So 2 into 1 by 3 to the power of minus n, u of minus n will have dtft as 2 by 1 minus 1 by 3 into e to the power of j omega. Okay. So now we'll take one more question. Find the dtft of sequence x of n is equal to, let's suppose 1, 2, 3, and 4 is x omega. Sorry, in this question it is written. The dtft of sequence xn is equal to 1, 2, 3, 4 is x omega. Find the inverse dtft of x of omega minus pi. So the solution for this question will be, let's suppose dtft of xn is given as x of omega. So e to the power of j omega into xn will have dtft of x of omega minus pi. Just wait for a second. So e to the power of j omega xn have dtft of x of omega minus pi. So now here I dtft of x of omega minus pi will become e to the power of j pi n xn. So this will become as x of n into minus 1 to the power of n. Okay. So here n is equal to 0, 1, 2, and 3. So when you substitute n is equal to 1, 2, 3, 4, that is at the index n is equal to 0, 1, 2, 3. So that will become minus 1 to the power of n. So here it will be 1 minus 2, 3, minus 4. Okay. For n is equal to 0, 1, 2, and 3. So now we will solve one more question. Find dtft of following signals. So here in the first question it is given as um, the signal is n into 0.2 to the power of 2n un. So let's suppose here, let's take g1n as n into 0.2 to the power of 2n u of n. So now this 0.2 to the power of 2 we can write as 0.04 to the power of n into u of n. So we know that 0.4 to the power of n un will have dtft as 1 by 1 minus 0.04 e to the power of minus j omega. Okay. So from the application of frequency differentiation using frequency differentiation, n into 0.04 to the power of n un will have dtft as j of d into d omega 1 by 1 minus 0.4 of e to the power of minus j omega. So this will become 0.4 e to the power of minus j omega divided by 1 minus 0.4 e to the power of minus j omega whole square, because it is multiplied with the n here. So this is just a simple question. So we will take one more example. So now we will see the Fourier transform pairs using inverse DTFT. Okay. So this time using inverse DTFT, x of omega, let's suppose, is summation of del of omega minus 2 pi k. Okay. K is equal to minus infinite to plus infinite. Sorry, this is x omega is given here. So we have to find the Fourier transform using inverse DTFT. So in this, we can draw this graph like this. This is x of omega. So this is 0, 2 pi, 4 pi, 6 pi. Okay. Minus 2 pi, minus 4 pi, minus 6 pi. So here we can write x omega is equal to del omega when omega is between from minus pi to pi. So let's suppose this is minus pi and this is pi. So this is simply as x omega is equal to del omega. So using IDTFT, what we can write x of n, that is equal to 1 by 2 pi integration of minus pi to pi x omega e to the power of j omega n dn d omega, that is equal to 1 by 2 pi minus pi to pi del omega into e to the power of j omega and d omega. Okay. So here we can write xn is equal to 1 by 2 pi e to the power of j omega n, omega is equal to 0. When omega is equal to 0, this xn will become 2 pi. Therefore, xn and x omega are the DTFT pairs. Okay. So our xn is equal to 1 by 2 omega, 2 pi. So 1 by 2 pi have DTFT as summation of del omega minus 2 pi k. K is equal to minus infinite to plus infinite. Okay. Therefore, 1 have DTFT as 2 pi into del of omega minus 2 pi k. K is equal to minus infinite to plus infinite. Okay. So now we will take one more example. An LTI system is specified by the equation y of n minus half of y of n minus 1 is equal to x of n. Okay, so we have to determine the frequency response and impulse response. So in this question, it is given y of n minus half of y of n minus 1 is equal to x of n. So when you take DTFT, y of omega minus half of e to the power of minus j omega y omega, this will become x of omega. Now take y omega as common. We will get 1 minus half of e to the power of minus j omega. This is equal to x of omega. So here h omega, that is equal to y of omega divided by x of omega. So this is equal to 1 by 1 minus half e to the power of minus j omega. Okay. So now taking IDTFT, h of n is equal to half to the power of n into u of n. Okay. So this is the value of hn, that is equal to half to the power of n into u of n. So now we will solve one more question. Two, three more questions we can solve. The frequency response h of omega of a system for impulse sequence responses h of n is equal to del of n plus del of n minus 1. So we have to find the frequency response h omega of an system for impulse sequence response, that is given as hn of n is equal to del n plus del of n minus 1. So here hn, that is given as del of n plus del of n minus 1. Here h omega, that is equal to 1 plus e to the power of minus j omega. So h omega, that is equal to 2 into e to the power minus j omega by 2 multiplied with e to the power of j omega by 2 plus e to the power minus j omega by 2 divided by 2. So h of omega, that is equal to, here it will become 2 cos of omega by 2 multiplied with e to the power minus j omega by 2. So h of omega, that is equal to 2 cos omega by 2, and the angle is minus omega by 2. Okay. So we will solve two more questions for today. So 5-point sequence xn is given as x of minus 3 is equal to 1 comma x of minus 2, that is equal to 1 comma x of minus 1, that is equal to 0 comma x of 0, that is equal to 5 comma x of 1, that is equal to 1. So let x of omega denote the discrete time Fourier transform of x of n. Then the value of integration of minus pi to pi x of omega d omega is. Four options are given for this question. A is 5, option B is 10 pi, option C is 16 pi, and option D is 5 plus j into 10 pi. Okay, so the solution for this question is x omega is equal to e to the power of 3j omega plus e to the power of 2j omega plus 0 plus 5 plus e to the power of minus j omega. Okay, because it is the integration of x omega d omega. Then minus pi to pi integration of e to the power of a j omega d omega, that is equal to 0 if a is not equal to 0. Therefore, e to the power of x omega d omega, that is equal to e to the power of 3j omega by 3j plus e to the power of 2j omega by 2j plus 5 omega plus e to the power minus j omega by minus j. Then here when you substitute pi and minus pi, it will become 5 pi plus 5 pi, that is equal to 10 pi. Okay. So now coming to the next question. Given x of n, that is equal to minus 1, 0, 1, 2, 1, 0, 1, 2, 1, 0, minus 1. Okay. So in this question, it is given x of n, that is minus 1, 0, 1, 2, 1, 0, 1, 2, 1, 0, and minus 1. And the DTFT of xn is x omega. So we have to perform the following operation without finding the DTFT of x omega. So the first operation is angle of x of omega. The second one is integration of x of omega d omega. Third of third part is minus pi to pi integration of mod of x omega square d omega. Okay. So in this question, so we'll first start with the first part, that is we have to find the angle of x omega. Since x of n is symmetric about 2, because here you can see About 2 it is symmetric 1 0 1 0 1 0 1 0. So angle of x omega is equal to minus of 2 omega. The second one, we have to find integration of x omega d omega from minus pi to pi. To find integration of x of omega from minus pi to pi d omega, consider x of n, that is equal to 1 by 2 pi integration over minus pi to pi x of omega e to the power of j omega and d omega. Okay. So at n is equal to 0, the x of 0, that is equal to 1 by 2 pi integration from minus pi to pi x of omega e to the power of 0 d of omega. So this will become 2 pi into x of 0. And our x of 0 value is 2 here. Okay. So this is our x of 0. So that will become 2 pi into 2, that is equal to 4 pi. Okay. Next is the third part, that we have to find the integration of x omega mod square with respect to d omega from minus pi to pi. So as per Parseval's theorem, summation of mod of xn square, n is equal to minus infinite to n is equal to plus infinite, that is given as 1 by 2 pi integration from minus pi to plus pi mod of x of omega square d omega. This is equal to minus pi to pi mod of x of omega square d omega, that is equal to 2 pi summation of mod of xn square. This will become 2 pi. Now we have to do the xn square. So we will square all these value 101, 210, 121 and 01. And we will sum it. It will become 1 plus 0 plus 1 plus 4 plus 1 plus 0 plus 1, 4 plus 1 plus 0 plus 1. It is like that only. If you square, minus 1 square is 1, then 0, 1, 4, 1, 0. So you can see 1, 0, 1, 4, 1, 0. And at last, 1, 4, 1, 0, 1. So here, 2 pi, this will be 2, 6, 7, 8, 12, 13, 14 into 14. So answer will be 28 pi. Okay. So this is a very simple question. So now we will see autocorrelation function and cross correlation function. And after that, today we will close this lecture here. So autocorrelation function. autocorrelation function ACF of discrete time signal x of n is given as r of x of k, that is equal to summation of x of n into x of n minus k. So here n is equal to minus infinite to infinite. So this will become x of n plus k into x of n. Okay. And also the properties of ACF is given as the first property as autocorrelation function is an even function of time k. This means r of x of k is equal to r of x of minus k. Second, r of x of 0, that is equal to e of x, that is equal to summation of n is equal to minus infinite to infinite x square of n. This is energy signal for energy signal. And r of x of 0 is equal to e of x, that is equal to limit n tends to infinite 1 by 2n plus 1 summation of n is equal to minus n to plus n x square of n. This is for power signal. The third property is r of x of k is equal to x of n convolution with x of minus n. Okay. And the fourth property is r of x of k, the dtft, is given as s of x of omega. This means autocorrelation function Rxk and PSP makes Fourier transform pair. And power spectral density x of x omega makes Fourier transform pair. The last one is cross correlation function. So it gives the correlation of sequence with shifted version of another sequence. The cross correlation function of two energy signal xn and yn is defined as r of xy of k, that is equal to summation of n is equal to minus infinite to infinite x of n y of n minus k. So this will become, like we can write like this also, x of n plus k into y of n. So it is even function of frequency. It is even function of frequency, that is r of xy of k is equal to r of yx of minus k. So today we will stop the lecture here only. If you guys have any doubt, then you can ask. And if you have any doubt, then you can ask on the YouTube chat box. I will reply there. Thank you everyone for attending the today's lecture.